To illustrate the assumptions and requirements of logistic regression, we're going to use the example donations. This is from the nonprofit.csv dataset. We're going to predict whether someone makes a donation, and to do that, we're going to use their age, their household income, their percent employment, so if you're fully employed 40 hours a week, that would be 100%, and the number of household dependents they have. So if you have a single man whose mother lives with him, that's one dependent for him. If you have two married people and they live in a house together and they have 3 children, then there are 4 household dependents. So that's how we're quantifying the number of people per household. A success would be receiving a donation for this nonprofit organization. So donation binary is the variable that we're interested in, and that's going to be a 1 if a donation was made and a 0 otherwise. So the model will look like this, with the log of the odds ratio equal to an intercept plus slopes in front of our 4 predictor variables. Now, writing the model, we would need to label P. P is the probability of receiving a donation. When we run this model in R, this is the output. You can see our coefficients and slopes, our intercept and slopes are all significant. So we're going to use this information to write out the model based on the estimates. And we see that the log odds ratio is equal to negative 7.93 minus 0.12 times age plus 0.00022 times income minus 4.86 times employment plus 0.43 times the number of dependents. Notice that age and employment status seem to decrease the odds that a person is going to donate. And income and number of dependents seem to increase the likelihood of receiving a donation. Of course, we need to say about all of these coefficients that this is an on average behavior. This is what tends to happen. It's not necessarily going to be true for each individual. And when we want to interpret the intercept, we would plug in 0 for everything. So we would say we have a person whose age is 0, income is 0, employed 0% of the week, and has 0 dependents. So we're really talking about like a newborn infant. And we see that in that case, the log odds ratio is negative 7.93. And what we've learned from our rule of thumb is that the more negative the log odds ratio is, the smaller the probability of success. So the question here is, does it make sense that a newborn infant is very unlikely to donate? And yes, that would agree with my intuition. A newborn infant has no idea that we even are interested in a donation. They don't have a sense that they should give a donation. They don't have any money to give. So it does make sense that a person whose age is 0 would not be donating. Then you have to ask yourself, do these coefficients make sense? Does each one gel with my intuition? And in this situation, you might not think that they do. As a person's age increases, does it make sense that they're less likely on average to give a donation? As their employment status increases, does it make sense that they might be less likely on average to make a donation? As their income increases, would they be more likely on average to donate? And as the number of dependents living in their household increases, does it make sense that they might be more likely to donate? It's okay if the model disagrees with our intuition. The model is representing what is true in the data on average, and our intuition can sometimes be flawed. Also, the data could be flawed. So just want you to be thinking about these things as we move forward. But this is the model we're going to use to illustrate some of the concepts about logistic regression.